Welcome to Old Iron Machine Works. In this video I will be working on a 10 horsepower motor that came out of my 1955 Monarch Series 61 lathe. This is some older footage of me cleaning up the lathe, blasting about 67 years worth of crud off of it. And anyway, this was a 100-degree day. I'm on cleaning, so everything dried real quick. And here we're ready to start tearing the motor apart. Motor weighs over 300 pounds. Now this motor has spent its whole life wired for 440 right from the factory. When I bought the lathe, it sat in the exact same shop since 1955. So later in the video I will show changing some of the wiring to 220. Even though this motor was very heavy, the end bells were actually pretty thin and fairly light, and there just wasn't really any place where I could get in and pry or beat on the thing to get the thing off. So I ended up tapping the holes to where I could run a bolt in there and use the bolt to help start pushing it apart. it was kind of being a little long-winded, so I ended up putting a puller on it. Yes, the puller is definitely overkill, but it's the only thing I had that was wide enough to catch the bolts. The inside of this motor was definitely pretty grungy, so everything went in the parts washer and got properly cleaned. Mentioned earlier, it's definitely overkill for the puller, but it's the only thing I had that was wide enough. And those bells, there just wasn't any good area where you can get any kind of pry bars or anything on it. So I thought this is the best way to get it apart. Now on this particular motor, there's no retainer plates or anything that hold the bearings into the end bells. The bearings press onto the shaft and then they just slip fit into the bells. Here you can see some old crusty wires that we'll address later in the video. Just a little mark I put in there when I was taking it apart. It just told me that that's the pulley side. Now the red you see is nothing more than the original primer of the motor. The wash cabinet does a very good job of cleaning it. Here you can see how thin wall these bells are. When it's all together, extremely strong. But wouldn't take a whole lot of prying and beating to end up, cracking it if you weren't careful. Now some people may not be real comfortable putting a stator in a wash cabinet. So if you're not comfortable, of course don't do it. I have done several motors where I've put it in a cabinet and washed them up good. The only thing is you just got to make sure that you properly dry them out before you ever put any power to them. Here I had the rotor cleaned up pretty nice, and since the motor isn't sealed up that great, I just wanted to give it a little bit of protection, you know, just in case it did get any moisture. And this is nothing more than just a clear coat. For the most part, the wash cabinet did a great job cleaning it, but on the very bottom, it didn't quite remove all the gunk from the bottom. You know, so here I'm just kind of scraping and got the vacuum going to get it cleaned out. Here it's time to clean up the wiring a little bit. It's got the old fabric outside on the wire with some rubber on the inside, and the rubber's all hard and brittle and cracking. And so what I decided to do, I was just going to put heat shrink tube over all the wires, and then cut off the ends and the tags on the wires, reinstall them. Here you can see the diagram, the way the motor's wired up. On the 440, you have leads 1, 2, and 3, which are your power leads. And then you have 3 groups of 2 wires hooked together. And when you go over to the 220, you'll see that you'll have 3 sets of 3 wires all connected together. And you'll see here where I changed the wiring and from 440 to 220. And here to connect some new wire leads to the motor, I will be using some copper split bolts to actually make my connections. And then there's the fusion tape that will go over the split bolts, and then black electrical tape over it. Now there's 9 wire leads on the motor, and each one is numbered. And these are the original bands that number the wire. And they wouldn't quite make it around the heat shrink tube. So I did some cutting and trimming, and then I kind of bend and rolled the end up on the one end, and it'll shove inside. And then when I heat it up with the heat shrink, it'll kind of shrink and grab that little barb at the end to hold them in. Right there was part of the tail on the aluminum tag that I kind of just folded it up, and then it just gave an area for the heat shrink to grab onto. I don't think it'll be pulling out once it cools. Here to protect the aluminum tag is nothing more than just some black electrical tape. The fine glass bead just kind of bounces right off of it. Here I'm just showing the combination for the 440 wires and a combination for the 220. Okay, I got my new lead wires all connected up, and now I'm just taking some of the fusion tape and going over the copper split bolts. And I normally put a couple, a couple layers of this, over it, and then I'll top it off with some black electrical tape. Now I'll finish doing the heat shrink on the rest of the blue heat shrink tubing. Rather than trying to do one at a time, I felt like it was better to just kind of heat them all up at the same time. Now the bearings that came out of the motor were NTN bearings made in Japan. I have no way of knowing if they were original to the motor or not. They could have very well been. But I do like a Japan bearing, and so I decided to go with the same NTN, and I just found these on eBay. Living in Northern California, we had an extremely wet January, and came in after a weekend, and it seemed like I had all kinds of stuff that flash rusted. Anyway, what I'm making here is a little support for pressing the bearings on. Many times I just put a bar across the bearing, set the bearing on, and press it in. But the rotor is fairly heavy, and I wanted to make I wanted to make a support, so when I press the bearing on, it's given equal support all the way around the bearing. I've done tons of bearings where I just set the bearing right across a couple bars and press it on, but on this particular one, I decided to just put in a little bit more effort, make a little tool, and do it the best that I possibly could. Now, when pressing the bearings on, you want to press the inner race of the bearing onto the shaft. You don't want to have pressure on the outside race, only the inside. So this little tool I made, once you set the bearing on there, it can only press on the inside. Off camera, I took this little brush and just some brake clean and kind of squirted brake clean down around the bottom and tried to get it as clean as possible, and it'll get resealed up. Right here, some red insulated varnish, and I kind of paint the whole inside with it. And here's after several coats applied. And now it's ready to reassemble. Here you can see just how big the openings are for the fan to move air from one side all the way across and out the other. Now I'm getting ready to put the pulley on the motor, and so before I do that, I pulled up some old footage. My lathe was a 700 RPM lathe. A friend of mine bought a parts machine, which was a 1000 RPM lathe, and I got a hold of Monarch, and the only difference between the 700 and the 1000 was the plate that gave the speeds and the pulley. That was the only difference. Thank you, Mike. Anyway, he gave me the pulley and the plate. among several other parts off of the lathe that I could put onto my lathe. So the set screws on the two pulleys were slightly off a little bit. So all I'm doing here is just putting another small little pocket for the head of the set screw to go into. The motor is now ready for some primer and paint. It's not too big of a deal since you don't really see the motor, but when I washed the bell in the wash cabinet, it did take the red off of the badge. But I am now wired up temporarily, ready to try the motor out. The fan definitely moves a lot of air across the motor. Well, hopefully the next video that I can put out regarding the Monarch Lathe will be it actually running. Get the motor in, I got to get some coils, do a little bit more electrical, and it should be ready to go. Anyway, I appreciate all my new subscribers. Appreciate everybody that takes the time to watch the videos and leaves a comment. If you like this kind of content, hit the subscribe button. And as always, I appreciate you taking the time to watch the video.